Sometimes the equations are not going to be set up in the form we want them to be. So I'm going to do one example like that, and then we're going to look at some horizontal parabolas as well, talk about that, and we may also look at this idea of, oh, if I know where the focus and the directrix are, how do I come up with the equation for the parabola? All right, so let's go back over here. Let's look at now, this time my equation is going to be set up like a more traditional parabola function. I'm going to say, let's say y equals 2x squared. Now, this looks like a pretty traditional quadratic function. We know that it's been vertically stretched by a factor of 2, but now we have this issue of, but I need to know where the focus and the directrix are, and there's a number in front of the x squared, okay, but there's no number in front of the y, which is what we want. We want it to be, 4py. So what we need to do here is we need to adjust the equation. We need to solve it for the x squared. We need to get the x squared alone. So I have y equals 2x squared. I'm going to divide both sides by 2, and so I get y divided by 2 equals x squared. Okay. Now there's a number over there on the same side of the equation where we want it, but it's not written like a coefficient. Okay. And this is where we need to remember how these coefficients work. Remember, if we have y divided by 2, that's the same as saying y times 1/2. So I can rewrite this as 1/2 y equals x squared. Okay. Now I have a value here, 1/2, okay, in the position where the 4p is. Okay. So I can now set 4p equal to 1/2, and then I'm dividing both sides by 4. So what that means, 1/2 divided by 4, that's the same as 1/2 times 1/4. So p now equals 1/8, which means I have a focus at 0, 1/8, and a directrix at y equals -1/8. So that is what we need to do when we have an equation set up where it's not in this new form where we want it to be x squared equals 4py. Solve for the x squared, get the x squared by itself, and then once again set that y's coefficient equal to 4p. You get the focus and the directrix. So this is kind of, I know this is kind of a new thing, but this is the next step in working with parabolas. One cool thing to note, let's go back here, and let me go back to a nice positive value here. Actually, let's go back to this. Another interesting thing about parabolas is there are a ton of real-life applications in ways that parabolas are used. Because the focus of a parabola is more than just, okay, we've got this focus, we've got this directrix, equidistant, etc. That's an important part of it. But another cool thing about the focus of a parabola is that if I'm drawing vertical lines, okay, or sending in rays straight down into the parabola, no matter where that ray comes in, okay, no matter where that signal comes in, it's going to bounce off of the parabola and go directly into the focus. So every ray that comes down into the parabola bounces directly into the focus. And there's a couple ways that we see this used. One is if you think about a satellite dish is actually just a really big, a three-dimensional parabola. So what we call a parabolic bowl. And a satellite dish always has that little thing pointing, sort of up above at the center of the bowl. That is the receiver, and that is at the focus. And so wherever the satellite dish is pointed, okay, it's receiving signals, and all those signals are being bounced off of the dish into that receiver that's at the focus of the parabola. Okay. Another way is if you've ever been at a sporting event and seen those guys on the sidelines that are holding those microphones that are sort of inside a bowl. That's the same idea. Okay, that bowl is a parabolic bowl, and so it's called. And so all the sound from the game that comes into it hits the bowl and bounces into the microphone. The microphone is positioned at the focus of that parabolic bowl. So just some kind of cool things about how parabolas are used in real life and everyday life. We also can have these parabolas that open left or right. Okay, and now we're looking at an equation where I have 4x equals y squared. Okay, so the idea is now we have y is being squared. Okay, and so the actual form for this would be 4px. I'll add a slider here, and let's make the focus and the directrix. So now, when I'm looking at a parabola in this form, okay, the focus is at p comma 0, and the directrix is at x equals negative p, because now the directrix is a vertical line. Okay, and so now we have these horizontal parabolas. They open left or right in this new form. And so you can have this type of parabola as well. So instead of 4py equaling x squared, if you have 4px equaling y squared, same principles, still working the same way, but now we're opening left or right instead of up or down.